All right, a couple more videos tonight before I go out in the cold and try to see the meteor shower. Eduardo asks, how are stars made and how do we know what they're made of? And I love that question because that lets me tell a story that took 10,000 years of human history to understand and is pretty amazing. So what we know is that from the beginning of the universe expanded very quickly, and it was pure energy. So there was no matter. It was too hot for that. And as the universe expanded, it cooled, and eventually early matter sort of congealed out of the pure energy of the universe. And then early matter was hydrogen and then helium, because they're the simplest elements. And then as the universe expanded and this matter cooled and cooled, eventually, due to changes in temperature, the atoms started moving around and they started to swirl and mix, and eventually they got close enough together, and the universe was big enough that gravity came to emerge, came to dominate the interactions, and eventually you started to get these swirling clouds of hydrogen and helium that eventually collapsed under their own gravitational attraction and became the first stars. And that's what happens when you have enough pressure and hydrogen, that the hydrogen atoms start smashing into each other hard enough to fuse and become helium atoms. And that continues. Most and stars sort of process helium and hydrogen and helium up the periodic table of the elements up to, I think, lead. I should know that, but it's late and I'm tired. Importantly, they don't create all of the elements, just some of them. And then we're still talking about a few billion years after the Big Bang, the early stars, and then some of them exploded because as stars run out of the lighter elements to fuse, they collapse because there is no longer as much pressure coming out from the center of the star. So the forces opposing that dominate and the star collapses. And then in many cases they explode in gigantic supernovas that distribute matter throughout the universe, including the heavier elements that were created in the star. So this has happened on, I believe, something like what we consider three generations of stars in the universe. Now there's lots more than that. But on average, I think the consensus is we are into the third generation generally of stars, and our stars is in that, the sun is in that group. Now, how do we know what they're made of? So over the last few hundred years, people have discovered that if you look at starlight, so just light from the sun, if you look at it through a prism, the white light from the sun is split into the spectrum, which is red, orange, yellow, green, blue, indigo, violet, red, orange, yellow. Yeah, I got it right. It's spread across whatever the light is shining on. And it turns out if you look closely enough, there's little vertical lines, there's little lines missing from that spectrum that represent the different elements that the light interacted with or reflected off of. And so over the 200 years ending about the early 20th century, scientists were cataloging what are called these spectra, which basically represent light patterns that represent certain elements. And so around the time that other chemistry experiments were being done and the periodic table itself was being developed, we came to have this catalog of what stars look like through a spectrum, what we call spectra. And that is how we look at stars through telescopes and determine what they're made of, or otherwise look at elements in space or on other planets. And so it turns out nature gives us this great tool to see what things are made of. And I think that answers your question, and this is a pretty long video, so thanks for listening, and ask any more questions if you have them.